Good afternoon. We're AnthroEnergy, and for this term of Hacking for Defense, we were tasked by the Joint Staff Office with powering isolated personnel recovery. Our initial focus was powering down fighter pilots to increase rescue probability. But after 143 interviews, we realized we were best positioned to more effectively power ground-based warfighters behind enemy lines at risk of becoming isolated personnel. We are David, a chemical engineering PhD student, Michael, a material scientist, and Jonathan and I are joint MBA Masters in Environmental Sciences students. In the last 10 weeks, we interviewed 143 people across services and functions, 74 beneficiaries, 13 private and military investors, 17 battery experts, 27 procurement and deployment experts, and 12 dual-use company representatives. Today, we're excited to share with you our journey, and we'll take you through our state of charge throughout our 10 weeks at Hacking for Defense. Our journey begins in week 0, when we lost our problem sponsor to the COVID-19 response. So instead of waiting, we got out of the building and took a bottom-up approach to identify use cases for flexible batteries within the military. In the first 2 weeks, we interviewed 41 warfighters and identified a myriad of use cases for flexible battery technology. They could be used in a flexible battery pack, medical devices, sensors, drones, and undersea equipment. Additionally, throughout our conversations, we developed a better understanding of the wide range of batteries used by ground operating warfighters and how dissatisfied these soldiers were with the existing batteries. Our best opportunity to contribute to battery usage would be to start with the smaller teams and special operations who iterate technology very quickly and efficiently. We then met our problem sponsor, who guided us to focus on downed fighter pilots at risk of becoming isolated personnel.
Unfortunately, after some interviews, we learned that pilots we interviewed did not see battery innovation as a top priority. Originally, we thought that because fighter pilots are at risk of being downed and stranded behind enemy lines, pilots would be most concerned with reliable batteries for communication. But we learned that power was specifically valued for periodic, infrequent use of CSAR radios. So overall, it didn't seem like they would need any changes to their batteries. Here we hit a bit of a dead end in customer discovery, and it was definitely a little frustrating at first that we weren't able to quickly find a beneficiary group. So working with our problem sponsor again, we decided to zoom out beyond just pilots and into the personnel recovery landscape as a whole. Our intention was that by doing so, we could hopefully pivot towards more suitable beneficiaries in the relevant area. After mapping out the personnel recovery process, we focused on something called a PR triangle, the communication relationship between ground recovery forces, air tankers, and helicopters. Specifically, we moved our attention toward guardian angels, composed of combat rescue officers, pararescue men, and survival specialists who are all keenly involved in personnel recovery. After learning more about the guardian angels, we found that they deeply cared about batteries. Extensive interviews show that there were a variety of problems they were eager to solve for their current batteries for their mission set, including weight distribution, low capacity, and lack of universal charging. Overall, battery management was a clear issue for this group. This was great news for us, and this ultimately became our pivot. The guardian angels were a beneficiary group that had a clear need for an improved battery product. This pivot from pilots to pararescue and ground recovery was a huge step. It enabled us to finally move from beneficiary discovery to product iteration. So our next step was to find out if we could come up with a minimum viable product to address their pain points.
Over the next 2 weeks, that's exactly what we did. We worked with the guardian angels to come up with the minimal viable product that you can see on the screen. You can see the AnthroEnergy batteries, which are flexible, safe, conformable, and have the ability to charge multiple devices here in the context of a warfighter's vest. They in fact can charge multiple devices, as you see on the screen, and we worked to identify exactly what the most key devices would be. And you might ask, what makes the AnthroEnergy solution different than other conformable batteries available today? And the answer is that it uses new technology developed by David in his PhD research at Stanford. The combination of this new technology the research with our beneficiaries, and our iteration towards the minimum viable product gave us product mission fit. So after that, the next step for us was to think about how do we take this solution and really put it in the hands of the people that need it most. And when we started to take a look at that, we realized deployment is quite complicated. We started by trying to figure out what organizations we would need buy-in and support from, and what organizations we would go through in order to deploy. And we started out by looking at groups like AFSOC and SOCOM, and deployment through dollars and resources provided by AFWorks and the Defense Innovation Unit. So we got out of the building and we talked to these folks, and we learned that there were several procurement options that could work, but unfortunately none of them were a great fit at first for us. Why is that? The conventional RFP process takes 5 to 7 years and would be very difficult for a startup company to go through. The SOCOM Other Transaction Authority was quick, but provided smaller value dollars and not necessarily an ongoing source of revenue. And the Defense Innovation Unit proposal made a bit more sense to us. However, the problem is that all of these routes require a technology readiness level of 6 or more. What that means in the context of AnthroEnergy is we needed a full-size prototype. And while we had proven out the technology in the lab, we did not have a fully functioning prototype yet.
This brought us to an emotional low point in our journey where we felt like we had done the work needed to identify a solution and the pathways to get it deployed, but simply did not have the technology. At this point, we realized that we were facing the valley of death. Taking promising lab scale technology and idea for a prototype to a technology readiness level of 6 that the Department of Defense would be interested in seemed insurmountable. However, by talking with the teaching team, our mentors, and other resources through the class, we realized that by pursuing a dual use business and identifying commercial applications for our technology, we could combine both early stage government support and commercial support to get to a technology readiness level that would allow us to deploy the solution. Specifically, before TRL level 6, we found opportunities such as the NSF SBIR and H4X labs that we can apply for to get resources in combination with venture capital funding from government-related VC firms such as IQT and NSIC, as well as conventional VCs. This will allow us to get to technology readiness level 6, at which point organizations such as AFWorks and the Defense Innovation Unit, in combination with manufacturing partners in larger scale venture capital dollars, can be combined to allow us to deploy not only in our target military market of AFSOC, but also for commercial sales in markets such as wearable electronics. With this pathway in mind, we ended on a positive note and are excited about the future of AnthroEnergy going forward. Next for us, we will all continue with AnthroEnergy in some capacity into the summer. We've been accepted into the StartX Accelerator program to further pursue the commercial side of the business and received a $50,000 grant from the Tomcat Center to develop the technology. We're also partnering with Lawrence Berkeley Lab in order to develop larger scale batteries with our improved technology. We're excited to make the next generation of safe and flexible batteries to improve warfighter performance. And if this is something that sounds interesting to you, feel free to contact us after this presentation. We need to give special thanks to our prom sponsor, Jeff Budis from the Joint Staff Office. He was a really great mentor, as well as Mark Breyer from IQT, who helped us locate a prom sponsor amidst all the craziness with COVID-19 at the beginning of the class. Our defense mentors, Warren Cook and Leo Liebrich, were awesome to talk to and really helped us a lot, as well as our business mentor, Rachel Costello. And so we owe these people many thanks. We really appreciate your time this evening, and we hope you enjoyed learning about our journey in Stanford Hacking for Defense. Thank you.
Good job.